Hey, welcome back everyone. This is lesson 4.4, day 1, proving triangles are congruent. So earlier videos I mentioned we're going to have some shortcuts to be able to prove that triangles are congruent. So prior to this lesson, the only way we could prove that triangles were congruent was all three sides and all three angles. But what mathematicians have found is that if we know the three sides are congruent, that's enough to prove that the triangles are congruent. So this postulate is called the side-side-side congruence postulate. And what that means is if three sides of the triangle are congruent to the three sides of the second triangle, then the triangles are congruent. So remember we said oftentimes we're going to be seeing these markings right here. So you can see that when I talk about that measure of ED, it's showing that it's the same thing as AB. If this has two markings, then it's congruent to this section, which is two markings also. So that's the BC is equal to EF. And finally, we have the third side. So if all you can do is prove that the sides are congruent, that's enough to make this congruent statement that the triangles themselves are congruent. So in our lesson today, we're going to be spending some time working on proofs. So here we have the first question, and oftentimes the first thing you're going to want to do is look at what's given and make some markings up here in your diagram. So it tells us that QU, which is this side, is congruent to AD, and QD is congruent to AU. So far we have two sides. So as long as we can get that third side, that's enough to be able to prove that they can be congruent. So remember, our first step in any proof is just to state what we have. And so our reason is given. Now look at this statement here. They're saying that DU is the same line. Well, of course that is. So that makes sense that this is the third side. So the property that says we can have du on both sides is our reflexive. Okay, so we have that all three sides are congruent. And again, the last line of your proof is just going to be what you wanted to prove. So we say triangle QUD is congruent to triangle ADU. And since we are using, or we know that we're in the side-side-side section, we can just say side-side-side. Okay, the next one, this one doesn't have any markings in it, so we'll go through and just make some notation. So it says that AC is congruent to AB. It says that D is the midpoint, which means that this section and this section are the same. And they want us to prove that the triangles are congruent. So we have this triangle and this triangle. So let's see, they wrote AC equals AB. Well, that is up here in the given. I'll look at the next statement that says that CD is equal to DB. Well, that's not stated specifically, but we can look at the way that it's written. Is since it's the midpoint, we can just, that part is actually given. And then since these are congruent, I skipped a step. I see that's the definition of midpoint. And so in this next one, they're talking about AD being congruent to itself. Remember, that's called the reflexive property. And since we have now all three sides, we can say that we can prove that those triangles are congruent by side-side-side.